Hey everyone, in this video we are going to discuss today's LeetCode contest, that is Biweekly Contest 189. So let's start with the first problem. Our first problem is elevator request 1. This is the first part of the problem. Here it is given that you are given an integer n denoting the number of floors in a building where the floors are numbered from 0 to n minus 1. You are also given an integer array requests where request represents the sequence of floor requests. An elevator starts at floor 0 and follows these rules. First rule is the elevator moves one floor per second. Second rule is the elevator serves request in the given order. Third rule is if the elevator is already on the requested floor, no movement is needed. And the fourth one is after serving a request, the elevator immediately starts moving towards the next request. Okay, so these are the four simple rules. Now at the end of this problem, you need to return the total time it requires to serve all the requests. Okay, so if you see the problem statement, it's pretty simple. It is given that we have a building of n floors from 0 to n minus 1 and we are given requests, right? In each request you are given which floor you need to move. Okay, and you need to process this request in the given order, right? So let's take the example of first sample test case. Okay, so here we are given that there are 5 floors and we are starting from floor 0. Okay, we are starting from floor 0. Okay, so in the first request you need to move to second floor. Okay, how much time does it take? It takes 2 minus 0, 2 seconds, right? And you are now at, currently you are at second floor. Okay, for the second request you need to move to first floor. So earlier you were on second floor. From second to first floor it will take 1 second. Now you are on first floor, right? And similarly on the third request you need to move to fourth floor. Earlier you were on first floor, so it takes 3 seconds. On the fourth one, how much time does it take to process fourth request? You need to move to third floor. Earlier you were on fourth floor. So how much time does it take? 4 minus 3, 1. So what is the total time? Total time is 7. Okay, so it takes 7 seconds to process all of the requests. Okay, this is correct. So the implementation is also very simple. We just need to iterate over the requests, right? Take a variable answer which will store the total time. Take a variable current, it will store the current floor, right? And as we are starting from floor equals to 0, so our current floor is 0. Now we will just process each request one by one, right? So you need to move to this floor u. So how much time does it take? It will take absolute value of current minus u. Okay, and now update your current variable to u. So this is how you can solve this problem. Let's move to the second problem of today's contest. Our second problem is minimum operations to make a rotation. Minimum operations to make a rotated palindrome 1. You are given a string S consisting of lowercase English letters. You can perform the following operations any number of times, including 0 and in any order. First operation is increment. Choose an index I and replace S of I with the next lowercase English letter. The letter after G is A. Left rotate. Move the first character of the string to the end. Return the minimum number of operations required to make S a palindrome. At the end you need to return a palindrome is a string that reads the same forward and backward. So your task in this problem is you need to return the minimum number of operations required to make as a palindrome string. Okay, and there are only two type of operations allowed here. First kind of operation is you can pick any of the index, let's say I, and you will increment the ith character by 1, right? Let's say A becomes B, C becomes D, similarly, and G becomes A, right? In a cyclic order you need to increment. The second kind of operations you can apply is you can left shift your current string by one position, means the first character, append the first character to the end of the string. Okay, so these are the only two operations allowed. You need to return the minimum number of operations required to make the string palindrome. Okay, so let's take an example of first sample. How can you solve the first sample test case? We are given this string ABC. Okay, so we can consider all of the possible cases, right? So if you think, let's say, when will you apply the first kind of operation? What is the first kind of operation? Increment operation. And can you think of, like, when will you apply second kind of operation, right? Second kind of operation is rotating this string by one position left. Okay, so you will see that you can say that I will, if there is a need, then I will always apply the second kind of operation, right, first. Okay, let's say at the end of the day, you applied X operations of type first, okay, type 1, and let's say you applied Y operations of type 2. Okay, then you will say that you will first apply Y operations of type 2, and then apply X operations of type 1. वाई इज इट सो? क्योंकि आप एक चीज़ सोचो कि आप एक स्ट्रिंग पर रोटेशन ऑपरेशन अप्लाई कर रहे हो. ओके, लेट्स से आपने इसको वाई टाइम्स रोटेट किया लेफ्ट, तो डज इट मैटर कि आप इनका ऑर्डर मैटर करता है? नहीं करता, राइट? आपको रोटेशन ऑपरेशन वाई टाइम्स अप्लाई करने हैं ना, तो इट डजेंट मैटर, आप कभी भी कर दो, राइट? आप सारे पहले अप्लाई कर दो, राइट? बाद में एक्स काइंड ऑफ ऑपरेशन अप्लाई कर दो, मतलब हर कोई भी इंडेक्स को चेंज कर दो इस नेक्स्ट कैरेक्टर पर. ओके, सो इट मेक्स सेंस टू फर्स्ट अप्लाई all type 2 operations first and then apply all type 1 operations. Okay, so now what we'll do is, if we take this sample test case ABC, we are given this string s equals to ABC, so first case is we do not apply any kind of left shift operations, right? So in this case your y equals to 0, right? That is second kind of operations are 0. Now how many first kind of operations are required to convert s into a palindrome, right? How you can do this? Let's analyze the string. This is our string, right? This middle element need not be same, right? What I mean is, this middle element can be anything, right? So we don't care about this. We only care about these two characters, first and the last. right? First and the third character, these two must be same for this string s to be palindrome. So there are two options. Either you convert a to c, right, or you convert c to a, right, and take the minimum. So what will be your value of x for this? Value of x will be minimum of how many operations are required to convert a to c? Two operations, right? Increment a to b, then b to c. So apply type 1 operations on a 2 times. Or another possible case is convert c to a, right? Converting c to a, how many operations does it need? It needs, you need to convert c to d, then e, f, g, h up till g, then again a, right? So how many operations does it need? It will need 26 minus 2, right? 26 minus 2 operations it will need. So what is the minimum of both of these? 2, right? So you will take minimum of both of these cases, either convert a to c or convert c to a. So for this particular case, our x equals to 2. Second case is, let's say you rotate your string leftwards by 1, right? Left shift this string s by 1 position. So your y will be 1 as you have applied 1 left shift operation, and x you need to find out. What is your string s right now? String s is bca, as we have shifted it 1 position left. Now bca, this we don't care, middle element, right? Our only worry is to make these two characters equal. So we will apply the similar thing here. What is the value of x? Value of x is minimum of, either convert b to a. How many operations will it need? It will need 26 minus 1, that is 25. And how many operations will it need to convert a into b? 1. So your value of x is 1. So here your value of x is 1. Similarly, the third case is y equals to 2, means you have shifted your s 2 times leftward. Okay. Now what is the value of x? Value of x we need to find. Your value of s is here CAB. Okay, CAB. This we don't care. We do need to make these two equal, right? Either convert C to B or convert B to C. So you will say that you will definitely convert B to C because it takes one operation, and converting C to B requires more than one operation. So you will take obviously minimum 1. So minimum is converting B to C, that is 1. So value of x is 1. Do you need to consider the fourth case when y equals to 3? You will say that no, we don't need to consider fourth case because only 3 case we need, only 3 second kind of operations we need to apply. If you apply the third, if you will apply the fourth operation of second kind, then what you will see, your value of s will be, what will be your value of s in the next operation? In the next operation, if you apply y equals to 3 and x, you need to find what will be value of s. S will be ABC, and this is exactly same as the first one, right? This is the one. So we need to rotate only n times. N is the length of the string, right? N plus 1th operation will convert it into the original string, that is, it was on the first operation. So here what we will do is, so what is the answer for the sample test case? You will take minimum of x plus y for all of these operations, x plus y for first kind is 2, for this one is 2, this one is 3. So you will say that 2 is our answer for this sample test case. Okay, 2 is our answer. Now how you will solve this problem for a general value of x. If you see the constraints on value of s, then you will see that there are order of 10 to power 3, right? So n square solution will pass here. So what we will do is we will do the exact same thing we discussed here in this sample test case. What we will do, we will iterate over y equals to 0 to y less than n y plus plus. Okay. So in this loop what we are doing is each time we are rotating our current string by one position leftwards. Okay, and now let's say we got a string s dash, right, after shifting by one position leftwards, and now we will find, you know, the value of y, right? You need to find the value of x. How you will find the value of x? You will just iterate over these characters, right? You will find the middle index, or you can say you will start from 0 to n minus 1. 0, you will take 2 pointers, I equals to 0 and j equals to n minus 1. Your 0 and n minus 1th character should be same. If they are not same, then increment the value of x by minimum of these two. Either convert si to sn minus 1 or convert sn minus 1 to si. What I am saying is, let's say if s of I is not equals to s of j, in this case what is your value of x? Value of x will be x plus equals to minimum of two values. What are these two values? Either convert si to sj or convert sj to si. Right? Minimum of both of these you will take and you will add it to value of x. You will do this for each of the indices from 0 to middle index. Okay, here this is how you can find the value of x, and you already know the value of y. So you will take the global minimum of x plus y. That is your answer. So let's see the code for this one. Okay, if you see the code, we have done the same thing. Initialized our answer with n into 26, that is the maximum possible value, right? Change each character by 26 times. Your answer can't be more than n into 26. Okay, now iterate over t equals to 0 to t less than n t plus plus. What is t? T is the number of times you have rotated your s left, right? The number of times you have shifted string s by one character position leftwards. Now what is the value of now what is current? Current is your value of x. Okay, current is your value of x. X matlab the total number of operations of first kind needed to apply on s dash, right, to convert it into palindrome. So we are doing the same thing. We are taking 2 pointers, I equals to 0, starting from I equals to 0, j equals to n minus 1. Keep on iterating while I is less than j, I plus plus j minus 1 is. Here we will check the position of the character si and position of character sj. If position 1 is greater than position 2, just swap, because we only need to care about converting one character to the another, right? So just assume that position 1 is less than position 2. If it is greater, then we will just swap it. Then take the minimum of both of these. What is the minimum? Either convert si to sj or convert sj to si. Means either converts the smaller character to larger character or convert the larger character to smaller character. Take the minimum of both of these. Here you after processing these, you know the value of x. Now what is the value of y? Value of y is t. So current plus t, take the minimum and replace s by shifting one character leftwards. What does this represent? This represents whole string excluding the first character. What does this represent? This represents the first character. So we haven't done anything else. We just appended the first character at the end of the string. Okay, and removed the first character from first position. So this is just one operation we have applied, and now this is how we will run this outer loop, that is applying the second kind of operations n times, and each time we will calculate our answer and we will take the global minimum and answer. At the end we will just return the value of answer, that is the global minimum of x plus y. Okay, so this is how we can solve this. Let's move to the third problem of today's contest. The third problem is kth digit in a finite string. So you are given an integer k. An infinite string is formed by concatenating the decimal representation of the positive integers without separators. For every non-negative integer b, block B contains the positive integers from 10 into b through 10 into b plus 9. The integers in each block are appended as follows. If b is even, append the integers in increasing order. If b is odd, append the integers in decreasing order. Therefore, the string starts with integers 1 to 9, followed by 19 through 10, then 20 to 29, then 39 through 30, and so on. You need to return the kth digit one indexed of this string. Okay, so the problem statement is pretty simple. You create an infinite string by following this process, right? You will create a blocks of integers, right? Each block is represented by 10 into b through 10 into b plus 9, right? B is starting from 0 up to infinity. And how you will append these integers to this infinite string, this is the given process. If b is even, then it means that you will append all integers of this particular block b in increasing order, right? And if b is odd, it means that you will append all of the integers of this block in decreasing order to this infinite string. What is your task in this problem? Your task is to find the kth digit of this infinite string. Okay, so how you will solve this problem? Let's take an example of first test case. So how will your infinite string look like? Your infinite string will look like s equals to, starting from first block. First block is special because it contains only integers from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the first block where b equals to are they taking 0 or no, they are taking 1. B equals to 0, right? 0 through 9, but in the first block you will not take 0 because you need to consider only positive integers. So basically we can say b equals to 0, right, to fit into this equation. Okay, what is the block 1? Block 1 integers are 10 to 19, right? 10 to 19. Replace b equals to 1 here. And if b is odd, then you will append the integers in decreasing order. So append the integers in decreasing order. 19, 18, 17, 16, 15, 14, 13, 12, 11, 10. This is your block b equals to 1. Similarly, you will append second block b equals to 2 in increasing order. As b equals to 2 is even, so you will append the second block in increasing order, right? What is the second block? Second block starting from 20 up to 29. So 20, 21, 29. This is your p equals to 2 block, means second block. Third block, as 3 is odd, you will append it in decreasing order. 39, 38 up to 30. This is your b equals to 3, and it will keep on going until infinity. Okay, so this is your infinity string. This is how it will look like. Now you need to, in the problem statement, you are given the value of k. You need to find the kth digit in this string. Okay, so first of all, if you analyze this, what you see here is, for the zeroth block, let's consider it differently, because this is a special block where it contains 9 digits. Okay, it contains 9 digits, a total of 9 digits, means a total of, I should say, 9 integers. It contains 9 integers. Now if you see carefully, except the zeroth block, every other block contains 10 digits, 10 integers. Second block also contains 10 integers. This also contains 10 integers. So except the first block you can handle separately. Except the first block, every other block, right? If you see zero based indices, so except the zeroth block, every other block starting from 1, 2, 3 up to infinity, every block contains 10 integers, right? So this is first observation. Now if you know the value of b, can you find the kth digit? It will be very easy for you, right? If you know the value of b, then in in each block there are only 10 integers, so you can just iterate over each integer. First you can see whether, if b is odd, then you will see that these integers are starting from 10 into b plus 9, and they will end at 10 into b if b is odd. Otherwise, let's say if b is even, in this case your integers will be starting at 10 into b up to 10 into b plus 9. So if you know the value of b, you can easily find the kth integer, right? So our first task is to find the value of b efficiently. So how you will do this? So first note that all integers in b, all integers in every block contains the same number of digits, right? So what you will do here is, you will iterate over the range of digits, right? So let's say you will iterate over the integers whose digits are 1. Let's say 1 you will handle differently, because it is a special case where it contains 9 integers in this block. You will start from d equals to 2, right? And you will keep on going, right, up to infinity. Now what you will do is, can you tell me what is the range of integers whose number of digits is 2? You will say that, yeah, definitely the range will be 10 to the power d minus 1 up to 10 to the power d minus 1. This is the range. This is the range of integers whose number of digits is d. Can you tell me, let's call this total, right? Total integers in this range. Can you tell me the number of blocks whose number of blocks whose each integer has d digits? You will say that yes, we can tell. How many blocks are there? Total divided by 10. How is it so? Because in each block you have 10 integers. So what is the number of blocks? Total divided by 10. So these are the number of blocks. So now what we will do here is we will iterate over the number of digits, right? First we will try to find the number of digits in our final block, number of digits in each integer in our final block. So we'll start from 2 and keep on increasing d by 1, and we will see that if k is greater than total into d, then what you will do is you will just simply move on. What you will do, you will just decrease k minus equals to total into d, right? And also increase the number of blocks. What is the total number of blocks? It elapsed here. Total number of blocks are total divided by 10, right? Do you know why we did total into d? In this range, can you tell me what is the total number of digits of all integers in this range? You will say that yeah, definitely. What is the total number of integers? Total. And what is the number of digits in each integer? D, right? So what is the total number of digits? Total into d. So if k is greater than total digits, then you will just decrease k by total into d and also increase the number of blocks. If k is less than equals to total into d, then what is the case? Then you know that the final integers in our block, the final block will contain d digits integers, right? Each integer in our final block will contain d digits. So now you found the value of d, and you also know here that each integer will be starting from d to the power 10 to the power d minus 1, right? And somewhere before 10 to the power d minus 1 your value of k will be there, right? Kth digit will be there. So here you will find the value of k. First you need to find the value of b, right? The block number. How can you find the block number? It is simple. You will just say that my block number will be plus equals to k minus 1 divided by 10 into d plus 1. Can you get it why we did this? These are the number, this is the final block. Think of it, why we did this. Okay, so the final block number is, so what are the number of blocks we will have to elapse, right, in this range 10 to the power d to 10 to the power d minus 1, 10 to the power d to 10 to the power d minus 1 to 10 to the power d minus 1. So you will say that for first k minus 1 digits, how many blocks will be there? each block has 10 into d digits. Why? Each block has 10 integers and each integer is consisting of d digits. So how many blocks will be there starting from 1 to kth digit? The number of blocks will be k minus 1 divided by 10 into d plus 1. So this is the final block we are able to find. Now you know the final block, right? Now what you will do is, now you will just iterate over value of each integer, right? Just iterate over, if b is odd, then you will iterate over 10 into b plus 9 up to 10 into b, right? And whenever your value of k satisfies this integer range, then you will stop there and return the kth digit of this integer, right? If b is even, you will do the same. You will just process these integers in increasing order. So this is how we can solve this problem. If you're still not able to understand this correctly, the implementation, how you will implement this, let's see the implementation. Okay, so we have done the same thing. First we have created this power function. It will basically calculate a to the power b. It is just a simple function. We could have improved it by using binary explanation, but it is not required here because b is very less. So just linear will work here. The second helper function is kth digit. If it will give us the kth digit of integer x. Okay, so this is also very simple. We have just extracted out all of the digits and reversed the digits. This is now basically digits in the right order, and you will just return the kth digit. K is here 1 based, so we have returned d of k minus 1. Okay, now see the actual implementation. First handle this case. First block case handle differently. If k is less than 10, it means it lies in the first block. You will just return the value of k, right? Because integers are the digits are in increasing order, 1 2 3 up to k, 1 2 3 up to 9. If k is greater than or equals to 10, then you know that this block will be greater than 0, right? It will be either first, second or third, right? Each block now will have 10 integers. Now we will do the same thing. We starting from b equals to 0, block equals to 0 we have processed here, and we decremented the value of k by 9 because we have just processed the first block, 0th block. Okay, 0th block contains 9 digits, 9 integers, and each digit have 9 integers, and each integer will have 1 digit. So just decrease k by 9. Now you will just iterate over the number of digits starting from 2 to infinity. You will calculate this total. What is the total? Total is actually the total number of integers in this range where each integer has d digits. Once you calculated this, you will check that if k is greater than total into d is the total number of digits in this range. If k is greater than, you will just decrease these total digits from k. You will increase the number of blocks elapsed here in this range and just continue. Now if k is less than or equals to total into d, this is where you know that in this range our block will lie, right? This is the range where our final block will be present. Okay, so just calculate the value of b, k minus 1 divided by 10 into d plus 1, and decrease the total digits before this final block in this range. What are they? They are the total number of blocks, that is 10 k minus 1 divided by 10 into d into that number of digits in each integer. What are the number of digits into the number of digits in each block. What are the number of integers in each block? There are 10 integers in each block into d. D is the number of digits in each integer. You know that, please note that all of the integers in this range will have same number of digits, that is d. Okay. Once you know the block number, final block number, you will just check the value of b. If it is even, then you will process the integers in increasing order. Otherwise, you will process the integers in decreasing order. And this is how you can check that if k is greater than d, means the current if k is greater than d, what does it mean? It means that your current integer does not have the kth digit value, right? Because k is already greater than d. It means that, and your current integer has d number of digits, so you will just decrease d from k, right, and continue. Otherwise, this case is where k is less than or equals to d, means your current integer will contain the kth digit. In this case, just return the kth digit of ith integer. Similarly, handle this case for odd. Just process these integers in decreasing order. So this is how you can solve this problem. Now let's move to the fourth problem of today's contest, that is elevator requests, second part. You are given an integer n denoting the number of floors in a building where the floors are numbered from 0 to n minus 1. You are also given an integer start representing the floor where each elevator begins, and integer where an integer array requests where request of I is a floor that the elevator is requested to reach. All floors in requests are distinct. At time 0, the elevator is on floor start and all requests are made simultaneously. Okay. During each second before all requests are filled, the elevator moves exactly one floor either up or down. A request is filled instantly when the elevator reaches its requested floor. If start appears in request, that request is already fulfilled at time 0. For each second that a request remains unfulfilled, you receive one penalty. Equivalently, a request fulfilled at time t contributes t to the total penalty. You need to return the minimum total penalty required to fulfill all the requests. So if you didn't get the problem statement, let me reiterate it. So what does this problem statement says is, you are given a building of n floors, each floor starting from 0 to n minus 1. Okay, and now you are given a list of requests, and these requests you are given all in these requests all floors are distinct, right? And these requests are given simultaneously, means all of these m requests in this list are given to you simultaneously at t equals to 0. Now you need to process this request one by one in any order you want, because the requests are given to you at t equals to 0 itself. You can move to you can process any request according to your need. The only thing you need to make sure is you need to process all of the requests at the end of your problem, and you need to return the total penalty you get. Now what is the penalty? The penalty is, let's say you are going to process the ith request. Now the total time you elapsed before processing the ith request is your penalty. Let's say you went to 10, let's say request of I equals to 10, means you need to go to 10th floor. Before the penalty for this will be, before I, the number of floors you might have processed, right, and they might have taken some time, let's say t time, and at the t time, at the tth time you went to 10th floor, then the penalty will be 10. So you need to return the sum of penalties of each request, and you need to minimize this total penalty. Okay, so if we take an example of sample test case, let's say this one. Okay, so there are 10 floors total, right? And you are starting from 5th floor, and requests are given this 0 to 9, 0 to 9. Okay, so you are currently at the 5th floor, right? And these are the requests 0, 2, and 9th floor, and currently you are at the 5th floor. So here what you can do is, let's move this side, right? Process the 2nd floor. What is the penalty to process 2nd floor? The time taken to reach 2nd floor, it is 5 minus 2, 3. So penalty for this will be 3. Now let's proceed to process this request. What is the penalty for this processing this request? That is the time taken to reach this, that will be 3 plus 2, that is 5. Now what you can do is, you can just go to 9th floor from 0. What is the total penalty? The total penalty will be total time taken from start to 9, that is 5 plus 9, 14. This is the penalty. So what is the total penalty? Total penalty is 5 plus 3 plus 14, that is 22. So this is your answer for this test case. You could have processed this request in any order. Let's say you are starting from 5, you could have moved to 9, then you could have moved to 0, then you could have moved to 2, and you calculate the total penalty. You will always see that this is the minimum penalty you can have, minimum total penalty you can have, right? Every other process will be having greater total penalty from 22. So this is your answer for this sample test case 22. Okay, so how you will solve this problem? If you see the constraints of this problem, these are n is 10 to the power 9 and the request dot length is 1500. So let's say m is the request dot length. Okay, so you can solve this problem in m square, order of m square, because m is order of 10 to the power 3 and 10 to the power 6 will pass. So order of m square solution will work here. So how you will solve this problem for a general given request array? What you can do is, you notice one thing here, that let's say you started processing some number of, this is your start, okay, this is your start, and these are the, let's say, how should I let me write it this way. Okay, so let's say these are your floor 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up till infinity, up till n minus 1. Okay, suppose that this is your start point and this is the request you are given. Here is also another request, 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 and here is also another request. Now what you will see here is, you will always cover a sub array of this floor array. What do I mean by this is, let's say you moved left side here, okay, then you moved 0, right? What do I mean by this is, let's say from starting from 4 you move to 2, then 0, then you will come to 5, then 6, 8, 10. Or this is one of the possible way. Another possible way is, you start from 4, move to 5, move to 8, you will just skip it. Is it worth skipping a floor between any two floors? No, it does not worth it, because just leave now, just stop here, because anyway you are going to take 1 second to move from one floor to second floor, one floor to next floor. So you will see that you will always cover a sub array, right? You will not skip any floor in between. So let's say if you started traversing towards right, this 5 you covered, 6 you covered, 8 you covered, now you can leave 10, you can come backwards and traverse 2. This is possible, right? And then again you can go to 10, and then again you can go to 0. So what do we see here is, it is guaranteed that you will always be covering a subarray, right? So as we are covering a subarray, what you can do is, now you can think of a dynamic programming approach here, right? So dynamic programming approach will look like this. So your dip is, you will create a dp of n cross n and 2, where dp of ij 0 will represent, dp of ij 0 will represent minimum total penalty minimum total penalty by covering, by processing requests from index I to j. ओके, dp ऑफ आई जे 0 क्या रिप्रेजेंट कर रहा है? द मिनिमम टोटल पेनल्टी बाय प्रोसेसिंग रिक्वेस्ट फ्रॉम इंडेक्स आई टू जे। मतलब आई टू जे एक सब, आई टू जे जो इंडेक्स है ऑफ दिस रिक्वेस्ट, ये आपने कवर कर लिया है। इस ये जो रिक्वेस्ट हैं, ये टोटल पेनल्टी कितना हमें कॉस्ट करेंगी, राइट? और सिमिलरली डीपी ऑफ, और 0 का क्या मतलब है इधर? आई जे, लेट्स सी आई आपका, ये जे है। 0 का मतलब ये लेफ्ट साइड में है, आपने पूरा कवर कर लिया है इसको, आपने इसको कवर कर लिया है, बट करंटली आप इधर हो, आई पर हो। डीपी ऑफ आई जे 1 क्या रिप्रेजेंट करेगा? डीपी ऑफ आई जे 1 क्या रिप्रेजेंट करेगा? मिनिमम टोटल पेनल्टी बाय प्रोसेसिंग रिक्वेस्ट फ्रॉम इंडेक्स 1 टू जे एंड एंडिंग एट जे। इसका हो जाएगा एंडिंग एट आई, एंडिंग एट आई, और इसमें हो जाएगा एंडिंग एट जे, राइट? ओके, this is the same thing. What is dp of ij1? minimum penalty by processing requests from index I to j ending at j. Okay, what will be your answer? Your answer will be, you can say that you need to cover all of the requests, you need to process all of the requests. So, and it doesn't matter at the end, are you it doesn't matter that in the end are you on the left side of the array or on the right side of the array, means you are on the 0th floor or n minus 1th floor. So you will just take the minimum, right? What will be your answer? Your answer will be minimum of dp of 0 n minus 1 0 comma dp of 0 n minus 1 1. This is your answer. Now only thing that is remaining is the dp of transition states. How you will calculate dp of ij0? So think of it like this. Let's say currently this is the block you have already covered dp of ij. This is your I plus 1. This is your j minus 1. Now how you will calculate dp of ij0? First of all, tell me what does it mean by dp of ij0? dp of ij0 means you have covered I to j, right? The total penalty by processing the request from I to j, right? And currently you are at 0. Currently you are at left, means I, left side of this processed floors, or you should say processed requests. Okay, so how you will calculate this dp transition state? So you will calculate it like, before reaching I, there are two positions, right? Either you were on the I plus 1 or you were on j, right? So just take the minimum. What is the minimum? dp of I plus 1 j. What does it mean? It means that you have covered I plus 1 to j and you are at this position, plus what is the total penalty what is the total penalty this move will incur? This move will incur means you will move from I plus 1 to I. What is the total penalty it will give us? The total penalty it will I should say the total penalty it will add to our final answer is, that will be, what is the total number of remaining requests? That is, currently the total number of processed requests are from I plus 1 to j. What is the remaining are total are m. So total m minus j plus I, right? So this is the total number of remaining elements, and each of this element will add this much penalty. What is this penalty? This penalty is request of I plus 1 minus request of I. This is the extra time it will take to reach I from I plus 1, right? So this time will be added as a penalty for all of the remaining elements, right? So this is what we have done here. M minus j plus 1, that is the total number of remaining elements, into request of j plus 1 minus request of I, that is the time taken to reach I from I plus 1. So this is the time which will act as a penalty for all of the remaining elements. So this is one of the case when you were at I plus 1 and you have covered I plus 1 to j. Another possible case is you were at j and you had covered I plus 1 to j, right? This is also another case. So you will do the same thing, dp of I plus 1 j 1 plus number of remaining elements m minus j plus I into request of j minus request of I, that is the time taken to reach I from j. So you will take minimum of both of these, and this will be your DP state. Similarly, for calculating DP of ij1, you will do the similar thing. What does it mean by DP of ij1? It means that you are, let's say this is I, this is j, I plus 1, j minus 1. So for DP of ij1, it means that you have covered I to j and you are at the jth, means right side. So there are two possibilities. Either earlier you had covered I to j minus 1 and you were at j minus 1, or another is you had covered I to j minus 1 and you were at ith, means on the left side of this covered plane. So you will take minimum of both of these, similar to how we took minimum of these two. So this is how you can calculate the DP transition states, and you will be able to calculate all of the DP transition states in order of n square time, right? And your answer will be the minimum of both of these DP states, that is covering all of the requests, and you are either on the left side or right side. So let's see the code for this problem. We have done the similar thing, right? This is very easy implementation. We have just defined an infinity, that is the infinity penalty we can have, that is 10 to power 18. We will always have a penalty always lesser than this infinity variable, right? So what we have done here is we have defined the DP state. DP state is m cross m. M is actually the length of requests, m cross 2, right? So we have defined this DP states, and we have sorted the request in increasing order, and m is the length of this request size, means request array. Okay, now this is the base case. Base case is you are starting, base case is initially you are at the start floor and you need to reach ith floor, means DP of I0, what does it represent? It means that you have covered request I, right? Or 0 means you are at the ith floor, and this will be actually same state, DP of II. It doesn't matter on the left side or right side because you are on the one index only, ith index. So both of these values will be same. And what is this value? You came from start floor to the ith floor. How much time does it take? It takes requests of I minus start, its absolute value. And how much penalty it will incur to our total penalty? How much penalty it will add to our total penalty? You will say that there are m requests pending, and each request will be adding this much penalty, right? So this is how we have initialized our DP states. Now what we will do is we will calculate the further DP states, that is outer loop is actually length starting from 1 to m minus 1, and inside this we are taking a length is actually the length of the covered segment. We will start, so in this base case what we have done is we have covered all of the segments whose length is 1. Now we will cover all of the segments whose length is 2, 3, 4 up to m. So L is equals to 1 basically means you are starting from I equals to 0 and I equals to 0 and j equals to 1, right? You will process 0, 1, then 1, 2, 2, 3, 3, 4, like this. So I and j is actually representing the same thing, that is the covered segment, and this is how you will calculate your DP state. So this is the same as we discussed in our solution. Okay, so this is how we can solve this problem using DP. So I hope you got the solutions to all of these 4 problems. If you still have any doubts, you can ask me in the comments. So this is it for this video. Have a nice day. Thank you.